Hi everybody. So I want to record this video as a sort of replacement for the meeting that we didn't have on last Tuesday, and to give my thoughts and suggestions as to the way forward based on the data that Nelvia sent us about the residential sector in Johannesburg and in Tshwane. I think the data that you were able to share, Nelvia, was fantastic, was really great. If I bring it up here, I'm going to focus on the data for the city of Johannesburg, but because it's the same for each, I don't think it really matters. The data that you shared with me includes the number of households who are cooking, who are heating, and who are lighting in each city using different types of fuels and technologies. So this information, this data gives us half of the equation for calculating the energy consumption and the emissions from the residential sector. So the other part of the equation that we need, the energy consumption, is equal to the percent of households cooking or heating or lighting. So the percentage of households doing something, let's take cooking as the example, multiplied by the energy intensity. So the energy intensity is the number of the amount of energy one household consumes using doing that activity, cooking, in a year. So it's the number of kilograms of wood consumed per year by one household that cooks with wood. It's the number of kilowatt hours of electricity consumed for cooking. The information that you shared with us, Nelvia, gives us the number of households doing each activity here. What I want to do in this video is show you how we can take this information that you've provided to me and enter it into Leap in a way that allows us to create the structure for the residential sector in Johannesburg or in Tshwane. And then I want to update you on some of the information that I've been able to find to get that energy intensity value, to be able to estimate the emissions. One thing that I just wanted to say about this data, I wasn't sure which year it was for, so I'm not sure which year to set up the Leap, the sort of base year for Leap at the moment, but I'll just pick an example when we do that. In Leap, what we need to do is to try and is to enter this data, is to enter it as the total number of households, which I've calculated by adding them together, and then the percentage of those households using the different types of fuels for cooking. So if we want to build this in a Leap data set, we can create a new data set. Let's call it residential Johannesburg. And now we've got a completely blank data set for us to create our residential sector analysis for. So in scope and scale, in our settings tab, I'm not going to make any changes. I'm going to assume that the data that you collected is for 2015. So at the moment I'm going to assume it's for 2015, and then we're going to start our scenarios from 2016, and then they're going to go to 2030. We can change all these values if that's a wrong assumption, or we could enter in multiple years of data if that's available. I'm now going to build the structure for my residential sector data. So I'm building it under energy demand because we're looking at the consumption of energy. And I'm going to create a new category called residential. So this is the number of households in Johannesburg. Now I could build this data set with the 130 wards if I wanted to. I could build this data set with each ward separately. So that's an option, and it's completely up to you as to how this data set can be built in a useful way. I'm going to build everything together just for the city of Johannesburg altogether, just for simplicity and to illustrate how to do this. So after my residential sector, I'm then going to add in sub-activities. So I might have cooking, and then under cooking, I'm going to add in my fuels and technologies. So I've got electricity, and then I'm going to add in the next fuel, which was natural gas. And then the next fuel was paraffin. I think in LEAP it's called kerosene. And then the next fuel is wood, then coal, animal dung, solar, other, and non. And I should have said that the best way to add in these fuels that have emissions associated with them is not to add them by doing what I just did and clicking add, but to click insert branch from other area. By doing this and inserting the branch from the ASIANA dataset, we can import all of the emission factors in one go to make this a much easier way of creating this data set. We don't need to then add in the emission factors at a later time. So I want to import the emission factors from the ASIANA dataset, and I don't want to import any of the other variables that I could. So I'm then going to select the residential sector, and I'm going to select natural gas from the other residential, just the general residential, and then click OK. And that now inserts the natural gas branch just as I'd done, but I've got the 11 pollutants, including PM2.5, NOx, other pollutants for natural gas. I'm then going to do the same for kerosene. Kerosene or paraffin. I'm going to do the same for let me just double check. I'm going to do the same for wood, coal, animal dung. Wood. So this gets a bit repetitive, but it saves a lot of time compared to having to add in all those emission factors later. Wood, charcoal, and then one more. And then I've got animal waste here. So then I have other categories. I've got solar. There's no direct emissions from that, so I'm just going to add that in. And then I've got other and non. So I'm going to add in branch for solar. And I'm going to add in a branch just called with non-energy and call it other. And I'm going to combine other and non because I don't know what fuel is used for other. Okay, so now I've got cooking. When I look at the heating and when I look at the lighting, it's similar types of fuels being used. So I'm going to copy cooking and paste it underneath residential and rename it heating. And I'm going to do the same, copy cooking lighting. For lighting, I can delete some of these. I've got electricity, gas, paraffin, and candles. I wasn't unsure about it saying not a valid option there. So for lighting, I can delete animal waste, I can delete wood, and I can delete charcoal. So I don't have any fuels that are not being used. Okay, and then I'm going to add one more branch for other electricity consumption. So there may also be electricity consumption from air conditioning, from water heating, from other appliances, TVs, microwaves, etc., that we will want to take into account. Okay, so that's the basic structure that we want to put in place in LEAP to be able to estimate the energy consumption and the emissions from the residential sector based on the data that you have available. Okay, so now we need to try and enter the data, but before we do that, we need to make sure that the units for our activity level are correct. The activity level that you have are the number of households, which is completely the correct activity level to have. So we want to change the units there to household. And here we can then enter in the total number of households in Johannesburg, which is 1434856. So I could just copy that and paste it there. That's the easiest way of importing data from Excel. Now, 100% of my households do some kind of cooking, 100% heating, 100% lighting, other. So now the bit I want to change is the percent of those households using different types of fuels and technologies. So 87.42% of people, let me put these spreadsheets side by side. 87.42% of people use electricity. 3.36% of people use natural gas. 8.08 paraffin. 0.23 wood. 0.08 charcoal. Animal waste 0.03%. Solar 0.17. And then non, I'm going to put as my remainder. So now we've entered the data that you collected for heating, for cooking, and we can do the same for heating. Let's move this over here and zoom in a bit. So for heating, 82.1% of people use electricity. 3.7% use natural gas. 4.73% use paraffin, 1.87 wood, 0.87 coal. So we need to add in coal. Let me just see. Sorry, I got charcoal and coal mixed up here. So we want to enter this as coal, not as charcoal. So let me insert the coal branch into cooking and heating here. And that will allow me to illustrate how we can copy and paste branches within a data set. So I'm going back to my Asiana dataset, selecting residential and selecting other bituminous coal and anthracite. So here I got it wrong. I'd entered 0.08% of households using charcoal, but actually it's 0.08% of households using coal. I'm then going to copy this branch and paste it under heating. So now I get this coal branch under heating as well. And the value that we want to enter there is 0.87%. Animal dung 0.1, solar 0.31, other, let's put that as our remainder 100. That includes people that have no heating. Then we get to lighting. So we have 90.81% of people using electricity, 0.19% of people using gas, paraffin 1.66, solar 0.22, and other will put as remainder 100. Okay. So we've now entered all of the data that you were able to collect for Johannesburg and Tshwane, and we've entered it for each of the activities in the residential sector. I've forgotten to do one thing, and that's change the type of percentage here for cooking, heating, lighting, and other. We use percentage share when we have a total value and we want to split it between different activities. So we might want to split our number of households between the different wards within Johannesburg and Tshwane. But it doesn't really make sense for cooking, heating, lighting, and other, because one household can do all of those activities. When that's the case, we don't want to use percent share, we want to use percent saturation. So we have the percent saturation of households doing each of these activities rather than the percent share. So that's the only change. So now we've entered all this data. But if we clicked on results, if I click on results, let's see if it works. I can click on results. I don't get any results. The energy consumption is listed as being 0. So I've broken down all my households into who cooks using wood versus electricity versus gas. I've split my heating the same and my lighting the same. But the key information that I haven't put in is then my energy intensity for each of those processes. So I've not put in how much one household cooking using electricity consumes, how much one household cooking using natural gas consumes. That's the key information we need to be able to complete the residential sector modelling to be able to accurately estimate the emissions. So with the data that UMFO had provided for Johannesburg, we have a estimate of the total energy electricity consumption in the residential sector in Johannesburg from the Eskom sales data. We know how many kilowatt hours are consumed in the residential sector, but what we don't have is what they're consumed for. How much energy is consumed for electricity, for cooking versus lighting versus heating versus other appliances. We don't have that information well established for these for in the residential sector from this data. We have the same problem when we look at gas consumption. So we have the total amount of gas that is consumed, but we don't know how much of that is for heating or how much of that is for lighting from these statistics. So these statistics are really helpful for looking at the total, but they don't tell us how it breaks down by activity. So if there's some information that we can use to break it down by activity, that would be really useful. So I've been trying to look for information about energy intensity for these different activities from different sources. And I came across this: how much energy does it take to cook with electricity for South Africa, this blog post. And they summarized information in this graph from a study here. From this study that looked at different types of meals. So they started with very simple meals that didn't take very much time to more complicated meals that took longer in South Africa, and they looked at how many kilowatt hours of electricity or paraffin or LPG were consumed using for cooking using different types of meals. So that's what's summarized in this graph here. It shows how much electricity it takes to cook rice or pasta versus a longer cooked meat stew. And it contrasts that for electricity versus paraffin versus LPG. What they conclude is that on a typical day, someone in South Africa, someone will cook a longer meal and then will cook a shorter meal. So there's two main cooking periods during the day, one for a long meal and one for a short meal. And the sum of the amount of energy consumed for a long meal plus the energy used for a short meal gives us the overall energy consumption if you're using electricity versus paraffin versus LPG gas. So I took the same approach and summarized here the total electricity consumption for each of these types of meals. And I assumed a boiled rice plus a longer cooked meat stew as being the two meals that are cooked per day to give an average. And then this gave me the total number of kilowatt hours consumed. The total number of kilowatt hours consumed using different types of fuel. So on average, 1.35 kilowatt hours per day is consumed cooking using electricity. 2.54 kilowatt hours are consumed per day using paraffin. 2.1 kilowatt hours per day using LPG. So from this study, we can then enter the number of kilowatt hours per household for each of these types of fuels, or at least for 3 of them. So for using electricity, we have 1.35. kilowatt hours per day. So we need 1.35 times 365. For natural gas, for paraffin, 2.54, 2.1 for natural gas, 2.1 times 365, and 2.54 times 365. So that's the information that we need to then to be able to estimate the emissions for each of these different processes. I have looked and searched and tried to find additional data on how we can estimate the energy consumption for heating and for lighting and for using these other types of fuels. And I will continue to search the literature for that information. But I wanted to record this video to highlight that we also need to know, on average in Johannesburg, how much electricity is consumed for heating in a particular home on a typical year. For natural gas, how much energy is consumed for heating. So we need to try and have that information to then see whether, when we add them all up, does it equal the total electricity consumption that we get from the Eskom sales. So I think that's where we are at the moment in terms of being able to estimate the emissions from the residential sector. And we can then estimate how this total number of households is going to change into the future and what that means for the emissions over time. So that's as far as I've got in terms of being able to take the data and create a LEAP data set. The key piece of information to complete the residential sector data is this energy intensity information, how much energy it takes to cook or heat or light or use other appliances in the home for each of these activities. If that data is available, then that would be really helpful. So I will stop this video here, and just to say that that's as far as we got. I hope it's been useful. Please let me know if you have any questions. Thank you very much.